Please open your textbooks to page 354. That's 354. Steve in second period. Josh and Wes in third period. Open your textbooks now. I know you haven't done it already. Let's go. Move. Once you get to page 354, you will see that we're doing lesson 8-5 on matrices and determinants. This is our fourth method of solving a simultaneous system of equations, and what for some of you combined with Cramer's rule will probably be your favorite way of solving the system. So our goal still is to find that one coordinate where the two equations, their graphs, will intersect. But we want to do it without graphing. We want to do it as quickly and easily as possible. And either this or elimination would be that quickest, easiest way. But in order to get to Cramer's rule and understand how to use it, first we need to have some background information. Like, what is a matrix? Not the movie, but mathematically speaking. That is a 2x2 matrix. A 2x2 matrix, and this is a 2x3 matrix. What a matrix is setting up numbers in rows and columns so that we can find what is called a determinant. This here is a 2x2 matrix. It has 2 rows and 2 columns. This is a 2x3 matrix. It has 2 rows and 3 columns. That's why they're called that. They're named by the number of rows and columns, making it up. The value of a 2x2 matrix, we find this. We say in order to find its value, we find the determinant of the matrix by finding the difference of the cross products. That's a lot of words. Difference of the cross products. Well, what does that mean? Here's what it means. The determinant is when we take something that's in matrix form, especially 2x2, and we cross multiply this way, and this way has to be first. Right? This letter, whatever number is up here where A would be, that has to be the way you go first. You cross multiply, that gives you a product, and then you cross multiply this way, this has to be second, and its value goes over here, then you subtract those two amounts. That's it. That's what a determinant is. So here I've been giving you matrix A, and we're going to find its determinant. So first I'm going to cross multiply this way and do 1 times 4. And from that I'm going to subtract the value of multiplying that way. 2 times a negative 3. So I'll multiply and then I subtract by the order of operation rules. This is 4 minus a negative 6. Well, minus a minus, notice I kept this this minus sign here in the middle, even though this is negative, because minus a negative number becomes plus. So this is 10. So its determinant, the determinant of matrix A right here, is 10. Well, now we're going to apply it to Cramer's rule. And this is what I've been mentioning for a while. Cramer was a Swiss mathematician who died in 1752, so he's been gone a while. This is not a new way. It's on the top of your book, top of page 355, talks about Cramer's rule. And the important part about Cramer's rule, and what I really need to emphasize and you need to notice, is that the equations must be in the form of ax plus by equals c. So it has to be in standard form. If it is not in standard form, you will not be able to do it. Well, most of our equations have been in standard form. The only ones that haven't been are those that we've graphed. But you could move those around. If you really like this method, you could move y over so it's with x, or move x over so x and y are together and the constant is by itself. But what we also need to notice is we're going to use just the coefficients of x, not the variable, and just the coefficients of y and the constants. So this involves all numbers, no variables, just the numbers. Go ahead and say it with me right now. 3, 2, 1. Just the numbers, no variables. So we're going to solve a system of equations using determinants. Now, the first time we go through this, it's going to seem like a lot of steps. So once you've done it a couple times, it gets much easier. All right, we're going to find 3 determinants to find the two coordinates. We're going to find 3 determinants. Well, if we find 3 determinants, that means we're going to have how many matrices? I hope you've said 3. You're going to have 3 matrices. You're going to have 3 determinants. You're going to have 3 matrices. That's the plural of matrix. Matrices. All right. The first matrix we're going to find is just this, a general one that will be on the bottom, because this is going to end up being a division problem. Define the variable x and define the variable y. First, you set up what will be the matrix, the number here on the bottom, because this is going to be a fraction. And this first matrix is the one using the 4 coefficients, the 2 x's and the 2 y's. And I will set it up 2 over negative 3 and negative 3 over 5. Notice the sign in front of the number, this negative sign here, went here with this 3 down here. And this negative 3 right here, this minus sign went with the 3 up top here. Now I'm going to find that determinant. So I cross multiply. 2 times 5 is 10 minus negative 3 times negative 3 is 9. So this first determinant on the bottom is a 1, which means, I'm out of room, which means that this determinant down here is also a 1. So let me rewrite this. Give us a little more room. The y coordinate is going to equal something divided by 1. Well, that means I'm going to end up dividing by 1, which means it's not going to change whatever the top number is. Define the variable of x. We look at our original 2 by 2 matrix we had here on the bottom. This side are the x coefficient, this side are the y coefficient. To find the x coefficient, to find the x coordinate, we're not going to use these x coefficients. We'll still use the y's, so these can go up here. But instead of using the x coefficients, we're going to put the constants in their place. So let's go back to this original system right here. These are my x coefficients. These are my y coefficients. And the 4 and the 1, those are my constants. And the constants are what I'm going to put in the place of the x coefficient to find my variable x. So I'm going to put a 4 there and a 1 there. Now I will cross multiply and subtract, just like I did here. The hardest part of this and the most crucial step is to set up your 2 by 2 matrix correctly. Because the math, the computation is easy. You just cross multiply and subtract. 4 times 5 is 20 minus, I'm always subtracting, 1 times negative 3 is negative 3. Well, minus the negative 3 becomes plus, and I get 23 over 1. So my x coordinate is 23. Now I'm going to find my y coordinate. Well, I already know the bottom. So I just have to set up the matrix that will give me the top number. Now, just like when we found the x coordinate, we couldn't use the x coefficients. When I find the y coordinate, guess what won't we use? We won't use the y coefficients. Instead of using the y coefficients here, we will use the constants right here. So I'm going to put my x's in there. My x coefficients will go in 2 and negative 3. But now I'm not going to use my y's. I'll use the 4 and the 1 in that place. There's a reason for that. It's a very long explanation in linear algebra. I really don't want to go into it, especially over a demonstration. And I'm not even there to answer your questions. But what we need to think of, when I'm finding x, I can't use the x coefficients. When I'm finding y, I can't use the y coefficients. That's one way to try and keep it straight in your mind. So I'll cross multiply here. 2 times 1 is 2 minus Negative 3 times 4 is negative 12. Add those two together. I get 14 over 1 is 14. So there's my y. 23, 14. That's my coordinate I'm looking for. It seems like a lot of steps. I know it does. It seems like a lot to keep straight. But it's really not that bad once you get used to it. I hope somebody has thought of this by now. What would be one of the most important things to be sure of? Well, as I look at this, I think one of the most important things to be sure of would be that I have my x coordinates, my x first, my y here, and then my constants right here, my numbers in this numbers. It has to be in that order, x, y, numbers. That way when you're setting up your matrix, it's always uniform and it's much easier. Now what I notice about this one is there's no number right here in front of my x. I'm going to go ahead and write in the number 1. That way when I set up my matrix, I don't have to look at it and say, oh, there's no coefficient there. Okay, what would I put in its place? That way I don't have to worry about that. All right. One thing I like to do, rather than setting it up all the time in advance and finding it, that bottom number under each one, I like to find it first, and then I'll just write the two numbers in its place. So I'm going to find the matrix using the 4 coefficients. That's what number goes on the bottom. So I have 3 and 1 and negative 7 and 2. I'm going to cross multiply. 3 times 2 is 6, minus 1 times negative 7 is negative 7. Add those, I get 13. So my bottom number, when I go to find each coordinate, is 13. And you have to have this as a fraction. That's the way Cramer's rule works. All right, now I'm going to set up my top matrix on my x, which means I do not use the x coordinates. I use the constants in their place. So I have negative 6 here and 11 here. And the y's are negative 7 and 2 on this side. Cross multiply. 6 times negative 2 is negative 12. Minus 11 times negative 7 is negative 77. So I get negative 12 plus 77 is 65 over 13, which is 5. So my x-coordinate is a 5. Now we'll find the y-coordinate, and since I'm finding y, I cannot use the y coefficients, so I put in my x's, 3 and 1. Now I'm going to put in my constants instead of the y, negative 6 and 11. Cross multiply. I have 33 minus 1 times negative 6 is negative 6 over 13. So that becomes plus. I get 39 over 13, which reduces to 3. So my coordinate, where those two lines for this system would intersect, is at 5, 3. Now some of you may be looking at this right now and thinking, boy, that's really not any easier than elimination. And that's fine. Some will like elimination, some will like Cramer's rule better. Personally, I've been working with this long enough, I can get through Cramer's rule pretty quickly, but I also can do elimination rather easily. So it's up to you. On the quiz, on the chapter test, you can use whatever way you want, whatever's easiest for you. All right, one more example. Let me set up my initial determinant for the bottom, set up the matrix. I have negative 3 over negative 2 and 5 and 7. Cross multiply, I get negative 21 minus a negative 10. Add, and I get negative 11. Alright, now I'm going to set up my matrix to find the top for x. So I cannot use the x coefficient. In its place, I'll use my two constants right here, 18 and negative 10. So 18, negative 10, and then I'll use my y coefficients, 5 and 7. Cross multiply. 18 times 7 is 126. Minus. Negative 10 times 5 is negative 50. Add those and I get 176 Oops, wrong size. And that's still over negative 11. So I get 176 over negative 11, which is 16. So it's negative 16. My x-coordinate's a negative 16. Now I need to find my y. So I can put my x coefficients in, negative 3 and negative 2. And then instead of the y's right here, I'll put the two constants, 18 and negative 10. Cross multiply, I get net 30, positive 30, minus a negative 36 over negative 11. So that becomes plus, that's 66 over negative 11, which is negative 6. All right, so negative 16, negative 6 up here. There's my ordered pair. That's the solution to my simultaneous system. Well, I hope you've seen that this is a little bit easier, and once you practice this enough, you can get much faster at this than you can any of the other ways of solving a simultaneous system. What you need to do, though, when you approach any of these systems, is you need to look and see how the equation is written, both of them. If they're in slope-intercept form, it might actually be faster to graph them, because you'd have to move them around to standard form first to do either not to do substitution, but to do elimination or the Cramer's rule. So when you're looking at these, look at the ones and see the way they're set up. That'll help determine what method to use. 1 to 7 and 11 to 27, all of those problems. So 1 to 7 all and 11 to 27 all, and it's on pages 356 and 357. Mr. Matthews, if anybody's not working on their homework, let me know. I expect them to be working right now, and if they're not, I will write them up tomorrow. Get to work. You have plenty to do. I'll see you tomorrow.